Welcome back to Q1 Week 4 Wednesday. So I'm going to go ahead and jump right in. Yes, I'm in my classroom today, free of animal distractions. So on our Wednesdays, we started with equivalent fractions. And again, any number, you can pick any number as long as you multiply the same number by the top and the bottom, the same exact number. So I picked 4 in this case. So 4 times 1 is 4, 4 times 2 is 8. I picked 5 in this case. 5 times 1 is 5, 5 times 3 is 15. Find the product. What I did here when finding the product was I used area model. I think area model is a fantastic way to multiply, especially when you have multi-digit numbers. It takes a while, but it ensures that you get the correct answer. So go ahead and use area model in this one. And once you eventually add all of them up, your answer should be 477,900. And this right here on the left is when I lined everything up, but not perfectly. I was not organized. So I made a mistake. So if you do not line up the place values correctly, you can definitely make a mistake right here. All right. Number 3, or the third box. A strip of paper is 9/10 of an inch long. You need to cut the paper into 3/12 inch pieces. How many pieces will you be able to cut? So we're going to be dividing in this case. So it's 9/10 divided by 3/12. But when we divide a fraction, we're actually multiplying it. And we use the KFC method, the keep, switch, flip. We're going to do it again on Thursdays. So I set up right here. I set up 9/10 times 12/3 because I flipped 3/12 into 12/3. I literally flipped it right here. So 12 times 9 gives me 108. 3 times 10 gives me 30. 30 goes, so that's my answer. And we can get a simplified answer by turning this improper into a mixed number. And I'm going to show you how. So you divide the bottom into the top. So 30 goes into 108 3 whole times. 3 times 30 gives me 90. So my remainder is 18/30. This is also the correct answer. But I could simplify it even further, and I'm going to divide it by 6 on the top and the bottom. So 6 goes into 18 3 times, and 6 goes into 35 times. So my most simplified answer is 3 wholes and 3/5. Okay. Finding the quotient for 17 into 6,613. Your answer is going to be 389, and I'm going to show you how I got that. So even though 389, this one is a whole number, I thought I was going to have to turn it into, I thought my quotient was going to end up being a decimal, but it wasn't. It went in there nice and evenly. So 17 goes into 66 3 times. 6 times 17 gives me 51. Okay, and go ahead and divide as you normally would, and that would definitely still bring you to the answer 389. You do not need a decimal for this one. Okay, I'm going to move on to finding the sum. That's adding. I'm not going to waste your time. You should have come up with 151 and 121. Finding the difference or subtracting, you should have come up with 43 and 345. Remember to line up the decimals when you add or subtract. All right, what's the LCM of 3 and 4? Remember, LCM is least common multiple, so you literally just need to skip count. You need to know your multiples. 3, 6, 9, 12, 4, 8, 12. My least common multiple is 12. Okay, what is the greatest common factor of 28 and 72? Well, I went ahead and set it up as a factor tree. So 28 and 72. 1 times 28 gives me 28. 2 times 14 gives me 28. And what else times 28 gives me 28? 3? How about 4? Yeah, 4. 4 times 7 gives me 28. Over here, 72. What 1 times 72, 2 times 36. And what else times 72 gives me 72? Is there a 4? There's not a 3, but there's a 4. 4 times what gives me 72? I'll give everyone just a few seconds because I definitely want you to get the hang of this one. Did you come up with an answer? So it's 4 and 18. So my greatest common factor is going to be, so GCF equals 4. Okay. Let's dive into Thursdays. I'm going to flip my spiral page here. Thursday. So this is an order of operation, and this is a division symbol. I had to look closely too. I thought it was an addition symbol, but it's a division symbol. So I just set up my problem here again, and I'm using carets to solve it. So 21 divided by 7 is 2, plus 6, plus 3 to the third power. Now next, I have an exponent. I did my P, now I have an E. 3 to the third power, or multiplying 3 3 times, is 27. So I crossed that out and I wrote the number 27 there. And then I continued as I normally would. So 6 plus 2 gives me 8, drop down 27, 27 plus 8 is 35. So my answer for this is 30. Not 36, it is 35. Finding the quotient of 15 goes into 4,378. This is going to bring you a decimal, not a remainder, a decimal. So 15 goes into 43 2 times, and I set it up here. 14 times 2 gives me 30. My difference is 13. I brought down the 7. 15 goes into 137 9 times. 9 times 15 is 135. The difference is 2. I brought down the 8. 15 goes into 28 only one time. Sorry, you can't read that number very well. One time. 1 times 15 is 15. My remainder is 13. Now I inserted a decimal, and I brought my decimal up, and I inserted a 0 here, and I brought my 0 all the way down here. Now 15 goes into 138 times. Remember, 8 is right on top of 0, not on top of the decimal, and moving along. And 8 times 15 gives me 120. And I'm going to stop right there because we're barely learning how to divide with decimals. So as long as you give me to the 10th place, we'll be good. So my answer should read 291.8 or and 8. Okay, this one is also fairly easy. I just keep switch flip. 4/5 times 7/3 equals 7 times 4 is 28. 5 times 3 is 15. 15 goes into 28 one whole time. My remainder is 13 over 15. I cannot simplify that any further. Okay, 12 goes into 5,434. My answer is going to be 452.8. And I want you to practice this one on your own right here. See if you came up with the same answer I did. It's the same as long division. We're not doing anything different except inserting a decimal and bringing it up. So practice, practice, practice with these. Finding the product. Your answer should have been 121.836 or and 836. Again, we should be very, very comfortable with finding products of decimals because we've been doing that in 4th and 5th grade. All right, finding the quotient. I am going to go over this one with you because this one has 2 decimals in the dividend and the divisor. So this is what I did. 2.6 is now becoming 26. However many times you move the decimal in the outside of the box is the exact same pattern you have to use on the inside of the box. So here's a little, this is not a U, this is me showing you that I moved the decimal one time. So now I need to move the decimal on the inside one time. So it's not 24 anymore, it's now 243. And then you plop that decimal right up there. That's the only difference if you have a decimal in both sections. You move it however many times it takes to make a whole number. And then you divide like you normally would. No big issue here. Okay? So go ahead and divide like you normally would in this section. All right, now I'm going to move on to this word problem. A red string of holiday lights blinks once every 3 seconds, while a string of blue lights blinks once every 4 seconds. How many times will both sets of lights blink at the same time in 1 minute? 60 seconds. Not gonna lie, this word problem was a little tricky, but I'm like, you know what? They just want me to find the least common multiple because that's what we've been doing. So the method I used is I literally skip counted 3 and 4 until I got to 60. And how many times did they have a common multiple? That's what the question is asking. How many times did they have a common multiple? So if you literally skip count 3 all the way to 60, it went up here. And 4, 8, 12, blah, 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 all the way to 60. Let's count how many multiples they have in common. So 12 is in common, that's the first. 24 and 24 is the second. 36 and 36, that's the third. 48 and 48 is the fourth. And then 60 and 60 is the fifth one. So they have 5 multiples in common. That's your answer. Your answer is 5 for this question, because it's asking for the same time. All right, our final question. Angie baked 100 cookies and 20 brownies. She wants to split them into equal groups for the bake sale. Each group must have the same number of cookies and brownies, with none left over. What's the greatest number of groups she can make? Well, if she has 100 cookies to 20 brownies, the greatest groups she can make actually is 20. Because for every 5 cookies, she gets 1 brownie. But it doesn't want to simplify. It wants the greatest groups. So the greatest in this case would be 20. All right, thank you, boys and girls. I hope this clarified a lot of it up for you. I'm trying to cut my video shorter because I know that is one of the big asks from you. So I'm hearing you. I'm cut them shorter so that way you can have more time to work through these. All right, bye.